posted the same 4 that I posted. And this is fall 2008, final exam. I think you said 22. That should be this one right here. Okay. So we're going to do that one, fall 2008, number 22. We got a 5-liter container at 18 degrees C. You've got 0.200 moles H2, 20 grams of CO2, 14 grams of O2. Exciting. I want to know the total pressure in the container, P total, and then the partial pressure of each gas. I'll put PI. But by that I mean partial pressure of H2, CO2, CO2, O2, etc. Okay. Do you want me to just kind of set it up? Would that be helpful? Yeah. Okay. So what I would do, is this in moles? Did I write that correctly? Moles? Okay, good. That number's awesome. Leave that alone. Take these numbers here. Is it okay if I just say change them to moles using the molar mass? So you want moles of CO2, moles of O2. Okay, that sounds like it made most people happy. Then, this is identical to the previous problem we just did with Dalton's law. By the way, I know it's Dalton's law because there's a mixture of gases and it talks about pressure. Okay, P total, N total, which is just the sum of all the moles from up here. You're just gonna boom, add those numbers up, put them right there. R, T, let's see, R is a constant, T is given, and divided by V, V is given. Oh, there we go. There's that one. And then, for the next part of the problem, let's just do it an example for hydrogen. That would be the moles of hydrogen over the total moles, which you just found the total moles. The moles of hydrogen are at the top of the, top of the screen. And then P total you just found as well. So P total is here. N total you would get from summing this up. And the moles of hydrogen up there. Is that okay? So you're going to just do this for every gas. Right there. Okay. Cool. Who's next?
Question.
Okay. On this. Okay.
To find the partial pressure of hydrogen, could you also use P equals nRT instead of where N is the number? Because you already know.
Yeah. Yes, that is true. Another way to find the partial pressure of hydrogen is to use P equals nRT. If I believe you have everything, you have the moles, you have the temperature, and you have the volume. Yeah, that should work fine. Good. Okay, we're good with this one? Okay, next. Yes? Do you have an example? This is exam 1 from my reader. 2015. Let me find that page first. Okay, my reader, this is page 28. What number? Oh, looks like number 3. Winter 15, my exam. Exam 1, not a final. Number 3. Okay, I'm going to try to just do this on the screen. Let's see if it works. Okay. I need to find all these multipliers so that these 3 equations add to that one up there at the top. I'm going to use a couple different colors to make this happen. Okay, my strategy is to first start with the overall reaction, which is listed right here. I'm going to ask myself, does carbon appear only twice in total? Yeah, it appears right there. I'll do a purple underline, and here. So I need these to match. I cannot change the overall reaction. So that means I need to multiply this second reaction of this list by what number? 2. 2. So then beta, if it's 2, the answer is B. But for fun, if you wanted to do the rest of it, you don't have to. I mean, if it's multiple choice, you should stop right there. Do other things. But let's get a different color. I'll do brown now. Hydrogen, does it appear only twice? Yeah. Here I'll do a brown box on hydrogen. Okay. So I need 1 in the reactants. I need to multiply this by just 1 because there's already in the reactants. So, cool. Yeah, still looks like B to me. And then finally, C2H2. Does that appear only once?
Yeah.
Okay, thank goodness. I'll put oval.
No.
Okay? I need to multiply, I need to get this in the products. It's in the reactants. It's in the wrong spot, so I need to flip this reaction, which also matches here. Okay? So, just kind of match it up, and if everything matches up, the multiply should come pretty fast. If you have multiple choice, it's pretty easy to figure out what the right answer is. Good. Next, yes? With the electrons? Okay. How do I do the filling in the molecular orbital diagram, say for the p orbital or something like that? For the pi, yeah, okay, so let's say we've got something like this. Let's say it's neon 2. I'll zoom out. Okay, I'm not going to draw all the edges. Okay, this is the sigma 2p, 2s. Sigma 2s star, sigma 2p, pi 2p, pi 2p star, sigma 2p star. Okay. You would have 4 electrons down here at the bottom. Is that okay? 2 from each side? It's because it's 2s2. 1, 2, 3, 4. For that part down there. For the upper part, each one of these would be a 2p6, or a total of 12. So you're going to go 1, and then you can't go up yet. It's too high of energy, it's better to pair. 2. Then go up. 3, you don't want to pair yet because that's too high of an energy. You'd rather go here. 4. Then pair. It's too high to go to the next level yet. 5, 6. Then go up. 7, 8. Then pair. 9, 10. Then go up again. 11, 12. It's full. I mean, it doesn't have to be a noble gas for that to occur. It's 2p6 is why it's full. So, and 12 fills this up. Okay, good? Okay, next, yes? Okay. I made an additional final, or like sample questions. What did you say, number 14? Okay, this is an isotope question. Remember those back in the day? I think I can just do this on this page. Okay. Let's do a different color though. Here we go. N14 to carbon 12 found to be a ratio of 1.167. Okay. I want to know this number. Its mass. Does anybody remember way back when we did isotopes, what atom was the reference atom? Carbon 12. Perfect. What was its reference mass? 12. That number is 12. That's unknown. Cross multiply. 12 times 1.167. Cool. Next. Yes, I'm going to make my way backwards. Yes. Somebody right here? Yeah. What page? 89 of my practice exam reader. Flipping over there. Okay, this looks like fall 2009. What number? 26? You said 26? The wine question. Okay, I was waiting for this question. The wine question. Fall 09, number 89. Okay. I'm going to have to do a different page. Again, it's follow 9, number 26. This one, you're mixing X milliliters of wine, which is 0.030 molar in sugar. So this is mixed with 20 milliliters of wine, which is 0.00010 molar in sugar. You're mixing those two wines. I know it might have been hard because you can't drink yet. You're not old enough, so I get it. And the resulting wine, so let's get a different color. This is mixed with another wine. I know, it's fun. 30 milliliters, make it thirsty. 0.0020 molar in sugar. The resulting wine, all of this, I'll put it equals 0.0020, oh no, 0.0015 molar in sugar. What's X? Cool. Okay, assuming that the volumes are additive. By the way, the resulting wine has what volume? Yeah, you do know. It's on the paper right now. 30 plus 20 plus X. Okay, so there's the result. It's just adding the volumes. You're literally mixing these wines together. Okay, so this is the resultant right here. This is a variation on a dilution problem, but more focused on the key concept, which is the moles initial equals the moles final. I've got this question so many times, which is totally understandable, that if you happen to have my reader, take a look at the bottom of page 31. It describes what I'm saying, in a couple sentences, and has another example if this one was confusing. Okay? So, but you can look at the bottom page 31 of my reader. Basically, you're setting the moles equal, meaning the moles of this here will equal the moles of this. So how do you get moles? Well, it's the molarity times the volume. So I'm just going to set up the molarity times the volume. Zoom out a little bit more. So I'll go X times 0.030 plus moles of the next one, 20 times 0.0001 plus the moles of the next one, 30 times 0. So see how I'm just multiplying the volume and the molarity? Equals 0.0015 times 50 plus X. There's only one variable, X, so solve for X. Variables right here and here. Okay, next. Okay, yes? This is winter 2009, number 9. So, they seem kind of the same to you? Okay. Winter 2009, number 9. So, I gotta find this. Give me just a second. Almost there. Okay. We're talking about this one right here? Okay. Which one has the largest radius? What I would always do is first of all go to the anion. Those are always the largest. So I'm kind of deciding between A and B. Okay? So arsenic and bromine. Because they're so close to the periodic table, it doesn't matter where they lie. So then I'm just going to go with the one with the largest negative charge, arsenic. They have the same electronic structure or electronic configuration, that's correct. But that electronic structure doesn't tell you what the radius is. So it doesn't matter that they're the same. It just matters which one has a larger negative charge. Why with something with larger negative charge? Because there's more electron-electron repulsion. Because you just keep adding electrons, none of them are like each other, so it keeps stretching out the size of the molecule. Yeah, good. Next. Yes, the two people next to each other.
Can I do question 27 of fall 2009?
Fall 09. Okay. Fall 9 practice final. Let me find that. You said 27, the balloon question? All right, this is the other question I get every quarter too. Also involves unfortunate amount of thinking. So I'm going to have to move this. So it's fall 09, page 89, number 27. Okay, you've got a balloon. The balloon has nitrogen dioxide. It's 1.20 liters. This reacts to form the dimer, dinitrogen tetroxide. 2/3 of it react. The temperature, pressure, and hence the total pressure in the balloon are kept constant. So T and P. What's the final volume of the balloon after the reaction is completed? Let's balance this reaction first of all. 2. Okay. It looks like the mole, because a reaction is occurring, the moles are changing. You can see going from 2 to 1. The other thing that's changing is the volume. So because moles and volume are changing, I'm going to go with one of those gas laws that looks like this. Okay? All right. Looks like we know the initial volume. So that's that right there. We want the final volume, I believe. Yeah, so this one, question mark. Here's the thoughtful part, is the moles. Figure out what the moles are. So let me rewrite the reaction. Okay. Give me a letter between A and Z. No, these two, they ask a question. I'm sorry, I cannot take W. Unless they approve it.
Yeah.
W. Okay. So, let's say there's W moles in the beginning. And in the beginning there's 0 moles of this. Okay? Let's see, how much reacted away? 2/3 react. So, minus 2/3 react. 2/3 of the W are gone. So it looks like we're just going to be left with 1/3 W. Is that okay? If 2/3 of it react? Okay. If 2/3 of that react, then how much do I make? Okay. Let's try. If that feels a little confusing, which I can get. Let's go 2/3 W. Let's do our, that's in, we're talking about moles here. So let's do a molar ratio, 1 mole, then 2O4, for every 2 moles, then O2. Looks like 1/3 W. So you make 1/3 W. In the reaction, add that to the amount we start with, 0. You have 1/3 W. Okay, we've done half of the thinking part. The other tough part is, well, first of all, what to put here. Okay, what's the initial moles? How many W's? 1, yeah. W goes right there. How many final moles? How many W's? Not 1/3. 2/3. Okay, let's get a different color pen. Think about why it was W in the beginning. You sum those numbers up. So W plus 0 is W. Why is it 2/3? 1/3 plus from the reactants left over, unreacted, plus another 1/3. So you plug that in, what you're going to notice is the W's will cancel. And so that way you'll be able to solve for the volume. No variable left over. Okay? Yeah, so two weird parts. One is this, and the other is what to put in. So to make this problem a little bit tougher. Okay, next. I was going to go to the very, very top. Was there anybody left up there? No? Flanking over here? No? Yes? I think I actually brought that. Nope, yes? No, it's not that. I imagined bringing it. Let's see. Oh yeah, here we go. Nope, I don't have it. I have to borrow yours. I made a review worksheet. I think McCurdy also sent out the same worksheet that I made. 22 on my review worksheet. What's your question about it? Okay. Okay, the question is, how did I pick, of all my answers, how did I pick the right one? Again, this is 22. Oh, I see why this is kind of weird. Yeah, that makes sense. Of these three, how did I pick the one on the left? I'm definitely not picking this one because of the -2. I think probably on the final we would have accepted either one of these. But if you're looking at the periodic, oh yeah. I would have accepted either one of those. Shoot, I could have said that way up there. Okay, yeah. So don't worry about deciphering those two. All right, who's next? Yes?
It's not on the practice exams, but it's
Okay, a secret something that you have right here. The balancing question. Okay, so I'm stealing your thing here. Okay, cool. I needed one, which is awesome. Okay. Oh, it's 9:30. Yeah, I think this will be the last question. Acidic or basic? It says acidic here, but you can choose. Can I show this to everybody? Okay, there's the question. So you want to, did you acidic? Is that what you chose? I mean, the top part is irrelevant. I just look at the reaction, balance it. Okay? All right, so what I would do is just split it up into half reactions. So step 1, balance the ions, they're already balanced. Step 2, balance the oxygens, there are none. Step 3, balance the hydrogens, there are none. Step 4, balance the charge. Okay, next. Step 2, balance the chlorines, 2. Or step 1, sorry. Step 2, balance the oxygens, plus 6 waters. 6 on each side. Step 3, balance the hydrogens, 12 there, wow. 12 here. Last step, balance the charge with electrons. 0 on the right. There's 12 minus 2, 10 here. I think it's 10. So then, you're going to take this and multiply by 10, and this and multiply by 1 to cause what I'm underlining right now to cancel. Okay? then there's that. So 10 ferrous ions plus 2 chlorate ions plus 12 H plus goes to 10 ferric ions plus chlorine plus 6 waters. There's your final answer. If you were changing over to basic conditions, I would add 12 hydroxides to both sides and then simplify after that. Sound good? All right, I hope people had a